Okay, in this lecture we want to learn about the proof of the derivative of exponential function. So we have y equals a to the exponent of x, and this is an exponential function. You know that the base is any positive real number except 1, and we want to find the derivative of this function. And this is our basically f of x. We want to find out f prime of x. How can we do this? So if we take the logarithm of both sides of this equation, you can take logarithm to any arbitrary base you want. We can take a natural logarithm of left side, and that's equal to natural logarithm of the right side. Okay, so ln of y is equal to ln of a to the x. Now, ln of y, considering that y is a function of x itself, we called it the u in the past, so would be u prime over u, in other words, y prime over y. So that's the derivative of a logarithmic function, y prime over y. And here we have ln of a to the exponent of x, where we can simplify it. We can write, of course, we could have simplified it before. We could have said this is x times ln of a, and ln of a is just a constant. And now, when we're differentiating a constant times x, it will be just a constant in front of x. So the answer will be just ln of a. So by a cross multiplication, ln of a times y becomes the derivative of a to the x. But we can, of course, substitute back. Instead of y, we can write a to the exponent of x, and then, of course, times ln of a, and that becomes f prime of x, or the derivative of the exponential function. So this becomes a formula. Now, if a is equal to e, the base of the natural logarithm, then we are going to have y equals e to the exponent of x, whose derivative would be e to the x, clearly, times ln of e. But ln of e is 1, I don't bother writing it, and we end up with a very interesting result here. This exponential function, e to the x, is the only, I repeat, the only function in the whole world of calculus whose derivative is equal to itself. All right? The derivative of e to the x is e to the x. But derivative of a to the x is a to the x times ln of a.